Section 12.3, surface area of pyramids and cones. A regular pyramid has a regular polygon for a base, and its height meets the base at its center. The slant height of the pyramid is the height of one of the triangular lateral faces. So all of our lateral faces are triangles. The base is any regular polygon. So that could be regular hexagon, regular pentagon, regular dodecagon, whatever you can come up with, but we know it's regular. So all of the sides of that base, that'd be our red shaded figure here, are going to be equal to each other, and all of the angles of that base are going to be equal as well, or congruent. The surface area for a regular pyramid is B plus 1/2 P times L, or that's B being our area of the base plus 1/2 the perimeter of the base times the slant height. Again, B is the area of our base, L is our slant height, P is the perimeter. If we want to use that formula to find the surface area of a pyramid, we first need to find the area of the base. So here, if we know we have a regular hexagon, we know regular hexagons are made up of 6 congruent equilateral triangles, so we use the area for an equilateral triangle to find one of those. That's our little triangle denoted there. We know that's going to be 1/4 the side squared times the square root of 3. Our side length is going to be 6. So we plug that in. 1/4 of 6 squared times the square root of 3. That's going to be the area of one of those little triangles. So we know the area of the base is going to be the area of all 6 of those triangles added together. So we can just multiply that answer by 6. So the area of one triangle would be 9 square roots of 3 times 6 would be 54 square roots of 3 for the whole base. So we know the surface area is going to be our base area, 54 square roots of 3, plus 1/2 the perimeter. We know the perimeter of our base is just that distance around the outside, so we have 6 for each side. We have 6 sides, that's where we get our 36, times our slant height, which we're given to be 8. When we multiply those out and add them together, we're going to get our surface area of approximately 237.5. Surface area of a right cone. Here we would have a picture of a right cone, very similar to pyramids, except we have a circle for a base. So the surface area here is going to be pi r squared, that's the area of our base, plus pi times our slant height. So we just plug in what we know. The surface area is going to be pi times 4 squared plus pi times 4 for our radius times our slant height, which is 6. So we're going to get 16 pi plus 24 pi, which is 40 pi, or approximately 125.6636. In this problem, we were asked to find the surface area of the cone and round to the nearest tenth. So we know from our last slide, surface area of a cone is going to equal pi r squared, or the area of our base, plus pi times our radius times our slant height. So then we just plug in what we know. We know the surface area is going to equal pi times our radius, which is 3, so pi times 3 squared, plus pi times our radius, which is 3, times our slant height, which is 4.5. So when we multiply those out, our surface area is going to equal 9 pi plus 13.5 pi, which is going to equal 22.5 pi, which is going to be approximately 70.7 centimeters squared. Here we're asked to find the surface area of the square pyramid to the nearest tenth. It's a square pyramid, so we know the base is a square. So first we're going to find the area of the base there. Alright, I guess first we're going to find the slant height. So we know the radius, they tell us, is 4. That's one side of our triangle, we're going to make a right triangle with the slant height and the actual height of the pyramid. The actual height they tell us is 6 meters. Our actual height is 6 meters here, this part of the triangle. Our base of that triangle is 4 meters. That's what they tell us right here. So then we can use the Pythagorean theorem to find our slant height. We know is a squared plus b squared equals c squared. So our slant height is going to equal 6 squared plus 4 squared. So 36 plus 16 is going to be 52. So our slant height is the square root of 52. Now we need to know the area of our base and the area of the perimeter, but the area of the base is just going to be 8 squared because it's a square. So we're going to have 64 for the area of the base. Our perimeter is going to be 8 times 4 because we have 4 equal sides. So our perimeter is going to be 32. So we know those two things. Then we can find the surface area of the pyramid by adding together. We know we just add the area of the base with 1/2 of our perimeter times our slant height. So we're going to have 1/2 of 32 times the square root of 52 plus 64. And that's going to equal approximately 179.4. And since we had meters, it's going to be square meters anytime we're dealing with any type of area. Area is in units squared, so our meters are squared. Here we are asked to find the surface area of the square pyramid to the nearest tenth. Again, we don't know the slant height, so the first thing we want to do is we want to find L. We want to find that slant height. That's going to equal, well, L squared is going to equal, since this is a right triangle, we know that if our side length is 6, that the little part of our triangle here is half of that, so that's going to be 3 inches. So then we can use our Pythagorean theorem. We know 3 squared plus 8 squared has to equal our L squared. So L squared is going to equal 73, which means our slant height is going to be the square root of 73. We know the perimeter of our square is just going to be 6 times 4, so that's going to be 24. And we know the area of our square is just our side length squared, so 6 squared is going to be 36. So then we plug that into our formula here. We know our surface area is going to equal the area of our base, which is 36, plus 1/2 our perimeter, which is 24, times our slant height, which is the square root of 73. So our surface area is going to equal 36 plus 12 square roots of 73. Then we're going to plug that into our calculator, and we're going to get, rounded to the nearest tenth, we're going to get 138.5 inches squared. Alright, here we are finding the surface area of this regular pyramid. We want to round to the nearest tenth. We know it has 1, 2, 3, 4, 5, 6 sides, so we're dealing with a hexagon. Our first step here, we want to find the perimeter of the base. If we've got 10.4 for one side, and we want to find the perimeter, which is all 6 sides, we just multiply by 6. So we're going to get 62.4 centimeters for our perimeter. Step 2, we want to find the length of the apothem and the area of the base. That apothem, we know the area of the base is just going to be 1/2 our apothem times the perimeter. So we already know the perimeter, so now we just need to find the apothem to find our area. So first we need to find our central angle. We know that's going to be 360 divided by 6, but our apothem always splits our little triangles into 2 equal parts, so that angle formed there is just half of that, which is going to be 30. Alright, so we can either use the fact that that's a special right triangle to know that we're going to end up with 9 as our apothem, or we can use trig. We know a times the tangent of 30 then is going to equal 5.2, or then dividing by the tangent of 30, 5.2 divided by the tangent of 30 is going to equal a, which is approximately 9. Again, that was a 30, 60, 90 triangle, so it might be quicker just to use our special right triangles. But then we know our area formula of a regular polygon is going to be 1/2 our perimeter times our apothem. So we're going to have 1/2 of 62.4 times 9, which is going to be approximately 281. So now we have the area of the base. The last step then is to find the surface area. We just plug that into our surface area formula, area of the base plus 1/2 our perimeter times our slant height. So we're going to have 1/2 62.4 from our perimeter times our slant height of 15 plus the area of our base, which is 281. Again, the book orders this in a little different way than we do sometimes, but either way we know we can add in any order. So if we do the half perimeter times slant height first, it does not change our answer at all. When we add those together, it's going to be approximately 749. So our answer is going to be 749 centimeters squared. Here we're asked to find the surface area of the regular pyramid and round to the nearest tenth. So first off, they give us the slant height, so we know L equals 9. So we need to find the area of the base and the perimeter. I'm going to start with the perimeter just because it's nice and easy. We know it is a 6-sided shape, 6 equal sides of 6, so we just have 6 times 6 for a perimeter, which is going to equal 36. Then we need to find the area of the base, which means we need to have the apothem. So we know the apothem is going to equal, well, first, I guess before we get to the apothem, we know that from the center straight down, that's going to be our apothem to the base. That's what we call little a. And we know to the vertex from that center point out, that's going to form that central angle. Since we have 6 sides, we know that central angle is going to be 60 degrees, because we'll have 360 divided by 6 for 60 degrees, so half of that is going to be 30. So we have a 30-degree angle there. But then we know the side across from 30 is going to be half of our side, which is going to be 3 then, since our side is 6. So we know then that the apothem, since this is a special triangle, is going to be x times the square root of 3. But we know x, they give us, since it's across from the 30-degree angle, x is 3. So a is going to be equal to 3 square roots of 3. So now we can find the area of the base, because our base is going to equal 1/2 the apothem, which is 3 square roots of 3, times our perimeter, which is 36. So the area of our base is going to equal 54 square roots of 3. So then we use the surface area formula. We know the surface area is going to equal the area of our base, which is 54 square roots of 3, plus 1/2 times our perimeter, which is 36, times our slant height, which is 9. Multiplying all of those out and adding together, we're going to end up getting 255.5 inches squared for a surface area. Alright, this leads us to the best problem ever. Yes, feel the excitement. We were able to find the surface area of a regular pyramid where the actual height is 6 and the radius of that inscribed pentagon is 5. The equation we're going to use for surface area, again, is our surface area equals the area of the base plus 1/2 times the perimeter times our slant height. So we need to find the area of the base first. That's going to be our area equals 1/2 times the apothem times the perimeter. And then lastly, we're going to end up needing to find the slant height of the lateral side using our Pythagorean theorem, because our real height is just from the top point of our pyramid straight down perpendicular to our base. that we said was 6. The radius was 5. So we'll be able to use the Pythagorean theorem to find our slant height. So let's start with our first step, finding the area of the base. Again, this is really just section 11.2. We know the area is equal to 1/2 the apothem times the perimeter. But we are only given a radius, so we need to find the apothem first. This is 5-sided. So we know we're going to have 360 divided by 5 to find the central angle. That's going to be 72. We divide that in half then because our apothem bisects that angle to be 36, so we form the right triangle you see here. So then we know the apothem is going to be 5 times the cosine of 36, since the apothem is adjacent, and we know that half of our side length, or x as we labeled it, is going to be 5 times the sine of 36, which we can get from these two formulas here. Cosine of 36 is going to be adjacent over hypotenuse, a over 5. Sine is opposite over hypotenuse. Alright, so if x is equal to 5 sine of 36, we know one side of our pentagon is going to be equal to 10 times the sine of 36. But we don't just want one side of the pentagon, we want the perimeter of that pentagon. So we're going to need to multiply that by 5 to get 50 sine of 36. So now we know the area of our pentagon is going to be equal to 1/2 our apothem, which is 5 cosine of 36, times our perimeter, 5 sine of 30, or 50 sine of 36, excuse me. Multiply that all out. Our area, or we'll leave it and we'll multiply it at the end so we don't have rounding error. The next step we need to find is the slant height. Our slant height is created by the triangle you see here. That h is our actual height of the pyramid. That's to the center of the base. The apothem is going, again, to the center of the side of one of those bases, and then our slant height is from where the apothem meets, or the midpoint of one of our sides, to the actual point of our pyramid. We know that our apothem was 5 cosine of 36, and the real height was 6 from the directions. So then we know 6 squared plus 5 cosine of 36 squared is going to equal our slant height squared. The key thing to remember here is that all of our apothem is squared. The 5 times the cosine of 36 is squared. Don't just square the 5, don't just square the cosine of 36. We need to find that product and then square. So then we know our slant height is going to equal the square root of 36 plus 5 cosine of 36 squared. And again, we'll save that till the end. And then lastly, we need to put all this information together to find our surface area. So our base is 1/2 of 5 cosine of 36 times 50 sine of 36. And our perimeter, which we gathered from that, is 50 sine of 36. Our lateral height is the square root of 36 plus 5 cosine of 36 squared. And we can use our surface area formula. Our area of our base plus 1/2 of the perimeter times our slant height. Plug all of those things in. Our calculators, yes, are getting very full, but we will have no rounding error until the end, which leaves our answer as accurate as possible. This is exactly how you're going to type it into your calculator. Parentheses in all of these spots. The only thing, after you type in your square root sign right in front of the square root of 36 here, you'll have an open parenthesis right in the front of the 36, and then you will close it again after you hit your squared key. After you type in 5 cosine of 36 squared. Make sure the parentheses are around the 5 and the end of the 36 at the end there. You need both of these parentheses here, and then there will be one on the end that closes off the one in front of the 36. Ooh, just like we have here. Make sure we have all of these parentheses in there. When all is said and done, our surface area is going to be approximately 165.774. Remember, units squared, if we had an actual unit measure, it would be on there and we'd square it. We can do this with any regular regularly based pyramid. So here we can do it with a regular octagon. We know the pyramid has an actual height of 8 and a radius of 5. We're going to follow the same process to find our surface area here. We know our surface area is going to be the area of the base plus 1/2 the perimeter times the slant height. Area of our base is going to be 1/2 apothem times perimeter, and then we use the slant height, or the Pythagorean theorem, to find the slant height. And then we throw it all into our equation. So let's start by finding the area of the base. We know an octagon is going to have a central angle of 45 degrees because 360 divided by 8 is 45. But the triangle that we need that uses the apothem and half of our side length is going to bisect that angle. So we're going to have 22.5 for an angle measure there. So then we know to find the apothem, we're going to use the cosine of 22.5, and to find the side length, we're going to use the sine of 22.5. Our apothem is going to equal 5 times the cosine of 22.5, and half of our side length, or x, is going to equal 5 times the sine of 22.5. But remember, we don't want half of that side length. To find our perimeter, we're going to need to have all of that side length, so we double it. That's going to equal 10 times the sine of 22.5, which means our perimeter, since we have an octagon, is going to be 8 times that amount, so that's going to be 80 sine of 22.5. So the area of our base here is going to be 1/2 our apothem, 5 cosine of 22.5, times 80 sine of 22.5. Our second step is to find the slant height. Again, we know we can use the Pythagorean theorem for this. Now that we know the apothem and we have our actual height, we can find the slant height. So we know our apothem is 5 cosine of 22.5. So if we square that and we square our actual height of 8, we're going to get our slant height. So our slant height is going to equal the square root of 64 plus 5 times the cosine of 22.5 squared. Again, remembering to square all of our 5 cosine of 22.5, not just one of the parts. Alright, our last step then, as always, for these awesome problems is to put all of our information together. We know our area of our base is 1/2 5 cosine of 22.5 times 80 sine of 22.5. And we know our perimeter is 80 sine of 22.5. And our slant height is the square root of 64 times 5 cosine of 22.5, all squared. So we plug that into our formula. Take our area of our base, we add it to 1/2 of our perimeter times our slant height. It's going to look something like this, but in our calculators we're going to plug it in as this down here. So we're going to have a bunch of parentheses in here. Just make sure that we close everything off. The calculator will open up parentheses for us after all of the trig functions and after the square root, so we need to make sure we close those off as well. One of the tricky things is making sure all of our division, the 1/2s, are both in parentheses, and we also want to make sure that the 5, or there's a parenthesis outside of the 5 and a second one after the 22.5. One closes off the trig that's going, or the angle that's going into our cosine, and then the other one closes off the parenthesis, making sure that we square all of 5 cosine of 22.5. Again, just make sure we type it in carefully so we don't end up with rounding error or mistakes. If we leave the first set of parentheses open, we could end up with something like 1 divided by 25 cosine of 22.5 there, or things of that nature. So we need to remember to close all of the parentheses that we open at the appropriate times. So our slant height, or our surface area here is going to be approximately 212.11. Here we're asked to find the surface area of a regular hexagonal pyramid with an actual height of 6 and a radius of 4. When we have hexagonal bases, we're pretty lucky. They're pretty awesome because they're broken down again into our 6 equilateral triangles. So we know immediately we can use the area of an equilateral triangle formula, or 1/4 our side squared times the square root of 3, to get one of those. triangles, but we know there's 6 of them throughout the base there, so we just multiply that by 6. We're going to end up with 24 square roots of 3 for the area of our base. Then our perimeter is not too bad to find either. Because this is equilateral triangle, we know the side length is going to be 4. We have 6 sides, so our total perimeter is going to end up being 24. So then the last thing we need to do is find the slant height. To do that, we're going to need to know the apothem so that we have 2 sides of our right triangle. So to find the apothem, we know we have a 30-60 triangle. Our base triangle is right there. And at this point, we know our hypotenuse of that is 4. If the hypotenuse is 4, then we know the bottom side, where we normally have an x, is going to be half of that, or 2, which means our apothem, which is in the spot where our x times the square root of 3 is just going to be 2 times the square root of 3. So that's our apothem. We can use that then to finish off our triangle here to find the slant height. We know 6 squared plus 2 squared, so 3 squared is going to equal our slant height squared. So we're going to have 36 plus 12 is going to equal 48. So we have the square root of 48 for a slant height, which is really 4 square roots of 3 when we simplify. So we plug all of that in. The area of our base was 24 times the square root of 3. The area of our perimeter, the perimeter was 24. And our slant height was 4 square roots of 3. Plug that all in. It's a much nicer formula than all of our trig functions thrown in there. And so our surface area is going to come out to be, again, making sure we have our parentheses correctly, our surface area is going to turn out to be 124.70765. But yes, again, always careful in our calculators with how we're plugging things in. 24 then, finding side lengths. If we were asked to find the value of x here, given that the surface area of this hexagonal pyramid is 231, note that they tell us the slant height is 6. This is going to get a little tricky. We know that our area of our base is going to be 6 times 1/4 times our side squared. And we know that our side is 3x. So we know the area of our base is going to be 6 times 1/4 times our 3x squared times the square root of 3. Again, that 6 is there because we have 6 of those equilateral triangles from our hexagon. And the area of each equilateral triangle is 1/4 times our side, which is 3x squared. Again, all of 3x is in parentheses, which means we need to square both the 3 and the x. So we're going to get really a 9x squared there over 1/4. So 9x squared over 1/4 times our 6 is going to give us our 54 over 4. X squared times the square root of 3. And then we know our surface area equals the area of the base plus 1/2 the perimeter times our slant height. They tell us that the surface area is 231. That's going to equal the area of our base, which is 27 over 2 times x squared times the square root of 3 plus 1/2 of our perimeter. Our perimeter is going to be our 3x times 6 because there's 6 sides, so it's 18x times our slant height, which we're told is 6. Alright, so then when we solve, we move the 231 over to get our happy zero so that we know we can use our quadratic formula. 27 over 2 times the square root of 3x squared plus 54x minus 231. We know we're going to have our a term, which is 27 over 2 square roots of 3. Our b is going to be 54, and c is going to be negative 231. We plug that into our quadratic formula. We know it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, like I was saying earlier, A is 27 over 2 square roots of 3, B is 54, C is negative 231. We can't forget the negative 231. If we made that a positive, that's going to throw our answer off here because a negative 4 times a negative 231 is going to end up being a positive number. So again, very complicated to plug into our calculators. Make sure we're doing it correctly. We're going to get x equals negative 54 plus or minus the square root of 2,916 plus 12,474 times the square root of 3 all over 27 square roots of 3. Alright, this is how we're going to plug it into our calculator. Again, making sure we have all of our parentheses aligned properly. X is going to be approximately 2.194 or negative 4.503. Again, we can do the same thing when we have a cone. Here we're finding the value of r given the surface area of the right cone is 219. They also tell us the slant height is 9. So the surface area of a cone we know is pi r squared plus pi times our slant height. So we plug what we know in. Surface area is 219. That's going to equal pi r squared, we don't know r, plus pi r times 9. Reordering, subtracting our 219 over to get our 0. Pi r squared plus 9 pi r minus 219 is going to equal 0. So we know we can use the quadratic formula again. Our a is going to be equal to pi, b is 9 pi, c is negative 219. So we plug those numbers in. We're going to have negative 9 pi plus or minus the square root of 9 pi squared. Again, all of 9 pi is squared, so we need to square both the 9 and the pi, minus 4 times pi times negative 219 all over 2 pi. In our calculator, we're going to type it in like this. That open parenthesis, negative 9 pi plus square root. When we type our square root into our calculator, it automatically opens up that parenthesis. That's the first one you see. And we want to make sure we have parentheses around the 9 pi because we're squaring both of those terms. And continue on through. X is going to be approximately negative 13.985 or 4.985. That's all we have for the lecture. I hope you were able to digest all of it. We'll have a homework check for tomorrow and be ready to start working on our homework checks in class, or you can start those tonight as well. Have a great day.